Hello all, welcome to binaryicons.com. In this video, I am going to show you how the ARP packets is actually work in your broadcast domain. In this lab, there are total 5 PCs. PC 0, 1, 2, 3, 4 and the one switch, and all 5 PCs are connected to the same switch. The PC 0 IP is 10.1.1.10, PC 1 IP is 10.1.1.20, 2 is 10.1.1.30 and 40 and 50. So I'm going to make a practical on PC1 on PC2 to show you that how the ARP protocol actually work. So this is a MAC address of PC1 to C25 and this is MAC address of PC2 for E496. Okay, so let me open the switch 1 CLI and type show MAC address table. You can see that the MAC address table is empty. Now run our simulator. In the simulator, in edit filter, I am going to use only the ARP packet. Select the ARP packet, go to the message right here in PC1 to PC2. Okay, now it's waiting to start. So in this case, the PC1 is our source and PC2 is the destination. In PC1, the IP address is the source IP address and MAC address is the source MAC address, and PC2 for this packet, the IP address is the destination IP address and MAC address is all F. So it's a broadcasting. So let me show you. Capture forward and this packet, go to the switch and let me open this packet. Okay, right here you can see that in layer and out layer, or you can also see in this inbound PDU packet. So there is a source MAC is 2C25 and this 2C25 is our PC1 MAC address. This is our source MAC address and the targeted MAC address is all zeros. So this is all F because PC1 don't know about the MAC address of PC2. In here you can also see this is the source MAC address of PC1 and destination MAC address is all F. The source IP address is 10.1.1.20. This is PC1 IP address and the destination IP address, that is a targeted IP address, is 10.1.1.30. So in this packet only one MAC address is displayed and the MAC address is the PC1. Let me open the switch and type that command show MAC address table, and you can see that the switch note that MAC address of PC1 in its MAC address table and the port FA02. So PC1 is connected to the port F02 and the MAC address of the PC1. Now let capture that forward packet and its packet go to the all PCs. And you see that it's broadcasting packet to all the connected PCs. The reason behind this is switch don't know about the MAC address of 10.1.1.30 because this is the destination IP address where packet want to go, but in MAC address field we put that all the F or all the zeros, so that is a broadcasting MAC address, so it will send that packet to all the connected ports. When the packet reach to the port like F01 and PC0 in this field, the PC0 capture that packet and it see that in destination IP address field the IP address is 10.1.1.30 and the PC0 is configured for 10.1.1.10. So PC0 is realized that this packet is not for me and it dropped that packet, and all other PCs also do the same thing. When the packet reach to PC2, it realized that the destination IP address is 10.1.1.30 and the PC2 IP address also a 10.1.1.30. So it realized that this packet is for me and it captured that packet, and in out layer he write his MAC address E496. Now let's forward this, and now PC2 reply back to PC1, so it's again send the packet to the switch. Let me open this packet. Now in this case PC2 is a source and PC1 is the destination. So the IP address of PC2 10.1.1.30 and the MAC address E496 is the source IP address and source MAC address respectively, and the PC1 IP address 10.1.1.20 and MAC address 2C25 is the destination IP address and MAC address respectively. You can see in layer the MAC address E496 is a source MAC address of PC2 and 2C25 is a destination MAC address of PC1. The PC2 know the destination MAC address and IP address of PC1 because when the first frame come to PC2 it contain the source IP address and MAC address. In inbound detail you can see that the source MAC is PC2 and targeted MAC is PC1. The source IP is 1.30 and targeted IP means the destination IP is 1.20. Now let's open the switch and type show MAC address, and you can see that the MAC address of PC2 is learned by switch and is note that MAC address in its MAC address table. So the PC2 is connected to the 05 port to the switch, and this is MAC address of PC2. Now the question is, when I click the forward button right here, switch will broadcast this packet or not? And the answer is it will not broadcast this packet on the other port because in this packet destination MAC address and IP address is filled. Okay, in this packet of source and destination field it contain the IP address and MAC address. There is no broadcast of IP and MAC. So switch know the destination MAC address and it is in its MAC address table. So our destination MAC address is this, and switch know this MAC address is going to the port F02. So it will send this packet only to F02 port right here to PC1. It will not broadcast that packet to PC0, 4 and 3. Let's see that. Press capture forward and it's only set that packet to PC1. It will not broadcast to PC0, 4 and 3, and it's reached to PC1 successfully. So in this case switch learn the two MAC address, that is PC1 and PC2. It's PC1 MAC address and PC2 MAC address. If I send the packet to all the PCs, like if I send this packet from this PC to this PC, this PC to this PC, switch will learn all the MAC addresses of the PC and it will not broadcast that packet if he know the MAC address of the particular port. So this is how the ARP packet actually work. Thanks for watching, and for more videos visit our website binaryhackers.com.